Hello friends, today we have the third session of our first chapter, relation and function. In first session, we have seen three types of relations, reflexive, symmetric and transitive. In second session, we have seen the example based on it. Now in the third session, we will learn today what is equivalence relation. Let us start with definition. Let R be a relation on a non-empty set A. Then R is said to be equivalence relation if and only if. These are the three conditions. The first one is R must be reflexive, R must be symmetric and R must be transitive. Let us revise before that. What is reflexive? For all A belongs to A comma A belongs to R. For all A comma B belongs to A comma B belongs to R implies B comma A belongs to R. Number 3, transitive. For all ABC belongs to AB is related to R, B is related to C, then A must be related to C. If these three conditions, in short I can say R, S, T. If your relation satisfies reflexive, symmetric and transitive, then it is called equivalence relation. Let us see one example. Let A is equal to 1, 2, 3. What is null set? Null set is subset of A cross A. So is a relation. Is it reflexive? Null set? No. Why? Because there is no A comma A belongs to R. Is it symmetric? If A is related to B, then B must be related to R. There is no such pair. So it is null set is not reflexive. What about symmetricity? Null set is symmetric. Why? Because the condition start with if AB belongs to R, then BA belongs to R. There is no such pair. Similarly, the transitive property start with A comma B belongs to R and B comma C belongs to R. Then we must have A comma C belongs to R. There is no such pair. So null set is also transitive. It is not reflexive. It is symmetric and transitive. Therefore, it is not equivalence. Why it is not equivalent relation? Because it is not reflexive. We must have all the three properties satisfied. Let us see the second example. R is equal to, let us say 1, 1, 1, 2, 1, 3, 2, 2, 3, 3. Now let us see whether it is reflexive or not. How many elements is there? 3 elements. 1, 2, 3. Let us see. 1 is related to 1, yes. 2 is related to 2, yes. 3 is related to 3, yes. So it is reflexive. 1 is related to 2, but 2 is not related to 1, so it is not symmetric. Let us see. R is reflexive. Number 2, R is not symmetric. Why? Because 1, 2 belongs to R, but 2, 1 does not belong to R. Now R is reflexive. We have seen 1, 1, 2, 2, 3, 3 belongs to R. So reason I can give, because for all A belongs to A comma A belongs to R. I have verified that 1, 1, 2, 2, 3, 3 belongs to R. So it is reflexive. What about transitive? 1 is related to 2, and 2 is related to 2. Again 1 related to 2. 1 related to 1, 1 related to 3. So 1 is related to 3. 1 related to 3, 3 related to 3. So 1 is related to 3. All the pairs are possible. R is transitive. That you can write in detail now. Then we will see afterward. We can write the reason which I have given. 1, 1 belongs to R, 1, 2 belongs to R. Therefore 1, 2 belongs to R. We can write for each pair. Let us see the third example. R is equal to 1, 1, 2, 2 and 3, 3. Again A is 1, 2, 3. That I have wrote out, so you can write A is equal to 1, 2. First one, R is reflexive, yes or no? It is reflexive. Why? You can see 1, 1 belongs to R, 2, 2 belongs to R, 3, 3 belongs to R, and A has only 3 elements. Is it symmetric? R is symmetric. Why? There is no pair such that A is related to B. No pair such that A comma B belongs to R and A is not equal to B. We have no such pair for which A comma belongs to R, A is not equal to B, so automatically it is a symmetry. Similarly, R is transitive because there is no pair for which A comma B belongs to R and B comma C belongs to R, such that A is not equal to B and B is not equal to C. So automatically is a transitive. So these relations satisfy all the three conditions: reflexive, symmetric and transitive. Therefore R is equivalence relation. Now let us start exercise 1.1 of our textbook. The first question 1, in that we have 5 questions. Let us take the first question. What is the first question? You can see in your textbook. A is equal to 1, 2, 3, 4 up to 14. R is equal to x comma y, where 3x minus y is equal to 0 and x and y belongs to A. This is the given definition of given example in your textbook. Let us write in the listing form. You can see here 3x is minus y is equal to 0, means I can say that 3x minus y equal to 0 implies y is equal to 3. Means y is 3 times the x. Your x is the first element and y is the second element. Here it is an order pair, so keep in mind. Let us take x is equal to 1 from the set A. You get y is equal to 3. Put x is equal to 2. You get 6. When I put x is equal to 3, you get y is equal to 9. And when you put x is equal to 4, you get y is equal to 12. I have put only 1, 2, 3, 4. I have not put 5. Why? Because if I put x is equal to 5, I will get y is equal to 15. And 15 is not there in A. So maximum possibility are these only, these 4 elements. I cannot put the value of x more than 4. Now first one, is it reflexive? Let us check it out. You can see there is no 1, 1. There is no 2, 2, no 3, 3. But one element is enough. 1, 1 does not belong to R. Therefore, R is not reflexive. What about symmetry? Also you can see for symmetry, you have the first element 1, 3 belongs to R, but 3, 1 does not belong to R. Remember the condition. What was our condition? A comma B belongs to R, then B comma A must belongs to R, but here does not belong to R. Therefore, R is not symmetric. What about transitive? Whether R is transitive or not. Let us check that also. For transitive, what I require? I must get a 2 pair. If A comma belongs to B and B comma belongs to C. 1 related to 3 and 3 related to 9. But 1 is not related to 9. Let us check it out that 1, 3 belongs to R. You can see clearly 1, 3 belongs to R and 3, 9 belongs to R. A is related to B, B is related to C. But 1, 9 does not belong to R. Therefore, R is not transitive. So what we got first example of textbook? The type of relation. It is not reflexive, not symmetric and not transitive. Now let us see the second example. R is the relation on N. N is a set of natural number. R is equal to x comma y is equal to x plus 5, x less than 4, x belongs to N. Now your x less than 4, the given relation is for only x less than 4 and x is a natural number. So what can be x? 1, 2 and 3. So what will be R? If I take x is equal to 1, y is equal to 1 plus 5, 6. If I make x is equal to 2, y is equal to 2 plus 5, that is 7. If I take x is equal to 3, 3 plus 5, 8. Is it reflexive? No. Why? Again, 1, 1. does not belong to R. Therefore, not reflexive. Is it symmetric? Answer is no. 1,6 belongs to R, but 6,1 does not belong to R. Number 3, is it transitive? Let us find the pair. For transitive, what we should have? We should find two pairs. A is related to B and B is related to C. We have only 3 elements. Let us check. 1 is related to 6, but 6 is not related to any other element. So I cannot find the pair. Same way, 2 is related to 7, but 7 is related to nobody. So I cannot find the second pair. Same way, I cannot find the second pair for 3, 8. Therefore, R is transitive. Reason you can say that there is no pair such that A is related to B and B related to C. So it is transitive. Let us see third example. Now let us see the third example of textbook. A is equal to 1, 2, 3, 4, 5, 6. R is equal to x, y. Y is divisible by x. X and y belongs to A. Let us form in the listing form. We know that 1 is divisible by 1. So 1, 1 belongs to R. Also 2 is divisible by 1. So 1, 2 belongs to R. 3 is divisible by 1. All the 6 elements will be divisible by 1. So 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6 belongs to R. Also 2 is divisible by 2. So 2, 2 belongs to R. 4 is divisible by 2. So 2, 4 belongs to R. 6 is divisible by 2. So 2, 6 belongs to R. Let us see for 3. 3 is divisible by 3. So 3, 3 belongs to R. Also 6 is divisible by 3. So 3, 6 belongs to R. 4 is divisible by 4. 5 is divisible by 5. 6 is divisible by 6. Therefore, there is no other such elements. In other words, we can see that y is divisible by x. What this means? This means that y is multiple of x. Now see, if I have to write all the elements who are related with 1, then what I have to take? All the multiple of 1. We know that 2, 3, 4, 5, 6 are multiple of 1. So 1, 1, 1, 2, 1, 3 all belongs to R. Now, for 2, we have to find all the multiple of 2 which are in A. So you can see 2 itself is a multiple of 2. 4 is multiple of 2, 6 is multiple of 2, so 2, 2, 2, 4, 2, 6 belongs to R. Also you can see that for 3, 3 is multiple of 3, so 3, 3. What is another element which is multiple of 3? You can see 6, there is no other element, so 3, 6 belongs to R. Let us think of 4. 4 is multiple of 4, so 4, 4 belongs to R. Now there is no other multiple of 4, so only 4, 4 belongs to R. Similarly, for 5, 5, there is no other element which is multiple of 5 except 5, and for 6 only 6 is the multiple of 6. There is no other multiple of 6. So these are the elements of R. Now let us see the first property of symmetry, reflexive. Is it reflexive? You can clearly see 1, 1, 2, 2, 3, 3 all belongs to R. For all A belongs to A, A belongs to R. Therefore, R is reflexive. What about symmetry? For symmetry, you can see 1, 2 belongs to R. You can see here, but 2, 1 does not belong to R. What this means? R is not symmetric. What about transitive? Now, for transitive, what we require? Two pairs such that A, B belongs to R and B, C belongs to R. So you can see here 1, 1 belongs to R. So I have to find all the pair which are related to 1. I have 6 pair. So it will be difficult to write that. Again, for 2, 2, the second element is 2. And how many such pair are there? 2 more pair. For 3 I have 1 pair. For this I have single. So it will be lengthy to write. So what I am going to do? I will solve this using property method. The same example can be done using property method, in which you don't have to list the elements. No need to list if you are using the property method. In last session also I have given one example of property method. Today we are saying the same thing. Okay. We know that x is divisible by x for all x. For any natural number, we can know that x is divisible by itself. Therefore, x comma x belongs to R for all x belongs to A. This is called property method. Without listing the element, I told that since x is divisible by x, x comma x belongs to R for all x belongs to R. So automatically R is reflexive. What about symmetry? For symmetry, you can see that if y is divisible by x, then it is not necessary that x is divisible by y. This is the basic property of divisible. Therefore, R is not symmetric. What about transitive? For transitive, you can see here. Let us start with two pairs. X comma y belongs to R, means y is divisible by x. And second pair, y comma z belongs to R. This means z is divisible by y. So I can write this. Y is divisible by x and z is divisible by y. Also, you can use the property of divisibility. Since z is divisible by y and y is divisible by x, I can say that z is divisible by x. Is the property of divisibility. So you can say that x comma z belongs to R. Therefore, R is transitive.